Hello guys, good morning. So let's go to our topic for the day, which is ano pala? Roots of equation. So I'm sure most of you familiar mo sa roots of equation. So how a roots are solved when a mathematical expression is given. So first, to understand what roots problems are and where they occur in engineering. Number two, to understand incremental search method and its shortcomings and to know how to solve a roots problem with the bisection methods. Usually, there are lots of methods on how to get the roots of an equation. Okay, so we will talk some of those as we go over to the topics. Okay, so roots of equation is defined as the value of x that makes f of x is equal to 0. So roots are sometimes called the zeros of the equation. So that's the definition of roots of equation. Okay? So usually yung equation, equate mo siya into 0 and you will compute for the value of x. So that's the roots of equation. So one example is the quadratic equation. So ax squared plus bx plus c is equal to 0. So how do you solve the quadratic equation for the value of x? So usually we have the formula for quadratic uh, equations which is equal to x is equal to minus b plus or minus square root of b squared. Hirap magsulat. Minus 4ac divided by 2a. So using this formula, quadratic formula, you can now solve for the values of x or its roots. So since this is a quadratic, so you can compute for the uh, two value of roots. So dalawa ang kanyang roots since ang atong exponent ay 2. So okay. So by the way guys, if you will compute for the roots, so dapat lagi mong equate yung equation mo into 0. Okay? Dapat masatisfy mo equation na mag-equal siya into 0. So there were also equations that could be solved directly. So there were many more that could not. So for example, even apparently simple functions such as f of x is equal to e raised to negative x minus x cannot be solved analytically. So in such instances, the only alternative is an approximate solution technique. Approximate lang ba? So one method to obtain an approximate solution is to plot the function and determine where it crosses the x-axis. So this point, which represents the x value for which f of x is equal to 0, is the root. So kung ang solution is by plotting the function, so ang ibig sabihin niyan is by graphical methods. So although graphical methods are useful for obtaining rough estimates of roots, so they are limited because of their lack of precision. So alternative approach is to use trial and error. So ang gagawin mo dyan, mag-guess ka ng value ng x. Then syempre evaluate mo kung yung f of x function is equal to 0. Kung mali yung guess mo, sa mag-guess ka na naman ulit. Then yung f of x evaluate na naman kung equal siya into 0. And the process is repeated until a guess is obtained that results in an f of x that is close to 0. Kaya lang napaka-inefficient siya at saka matagal, no? It will take you more time kung puro ka guess then evaluate mo ulit yung value ng f of x. Okay, so one example of the equation derived from Newton's second law for the parachutist velocity, which we computed for lesson 1, wherein the velocity is equal to g multiplied by m divided by c times 1 minus e raised to negative c divided by m times t plus parenthesis, where v is the velocity, t is the time, and g is the gravitational constant, and c is the drag coefficient, and m is the mass. Okay, so such computation can be performed directly because b is expressed explicitly as a function of time. So that is, it's isolated on one side of the equal sign. Pero suppose we had to determine the drag coefficient for a parachutist of a given mass to attain a prescribed velocity in a set time period. So there is no way to arrange the equation, no? So that c is isolated on one side of the equal sign. So in such case, c is said to be implicit. So to solve the problem using numerical methods, so we'll express the equation, which is done by subtracting the dependent variable v from both sides of the equation to give f of c is equal to gm divided by c multiplied by 1 minus e raised to c divided by m times t minus b. So kung itong equation, dinivide lang natin siya ng b. Okay. So the value of c that makes f of c is equal to 0 is therefore the root of the equation. So this value also represents the drag coefficient that solves the design problem. So here are some fundamental principles used in engineering design problem. So kung na lang bahala magbasa ng table PT 2.1 and focus on mass balance and force balance and energy balance, Newton's law of motion. Yan. Okay. So by definition, a function given by y is equal to f of x is algebraic if it can be expressed in the form fn y raised to n plus fn minus 1 times y raised to n minus 1 plus f of 1y plus f of 0 is equal to 0. So where f of I is equal to an ith order polynomial in x. So polynomials are a simple class of algebraic functions that are represented generally by fn. X is equal to a of 0 plus a1x plus a2x squared plus and so on so forth, where n is the order of the polynomial and the s is the constant. So some specific examples are f of 2 of x is equals to 1 minus 2.37x plus 7.5 x squared, and f of 6 of x is equal to 5x squared minus x cubed plus 7x. So if you will notice kung ano yung exponent, pinakamalaking exponent, yun yung f of n. 2. Kung 6, pinakamalaking exponent, f of 6x. Okay? So these are some example of polynomials. Ito. They are simple and class. So pag may mga raise, mga exponent na ganyan, x lang. Walang masyadong ibang variables, polynomial siya. Okay? Then let's go to transcendental function is one that is non-algebraic. So ano ba yung mga transcendental functions? It include trigonometric function, exponential, logarithmic, and other less familiar functions. So example of trigonometric, yung sine, cosine, tangent, yung mga ganun. Then logarithmic, ln x squared minus 1. An exponential naman, f of x is equal to e, mga ganyan example. So roots of equation may be either real or complex. So although there are cases where complex roots of non-polynomials are of interest, so such situations are less common than for polynomials. So as a consequence, the standard methods for locating roots typically fall into two somewhat related but primarily distinct problem areas. So number one, the determination of the real roots. Real roots of algebraic and transcendental equations. So these techniques are usually designed to determine the value of a single real root on the basis of foreknowledge of its approximate location. Number two, the determination of all real and complex roots of polynomials. So these methods are specifically designed for polynomials. So they systematically determine all the roots of the polynomial rather than determining a single root given an approximate location. So one method in finding the roots of equations uh, is by bracketing method. So these techniques are on roots of equation that exploit the fact that a function typically changes sign in the vicinity of a root. So as the name implies, these guesses must bracket or be on either side of the root. So the particular methods described herein employ different strategies to systematically reduce the width of the bracket and hence home in on the correct answer. So under bracketing methods, we have the graphical methods, bisection methods, and the false falsy methods. So in bracketing method, there should be two initial guesses for the roots are required. So these guesses must be bracket or be in either side of the root. So if one real if one root of a real and continuous function f of x equal to 0, so it's bounded by values of x is equal to xl or the lower value, or x is equal to xu or the upper x value. So it should be the function of xl or f of x u must be less than 0. So the function changes sign on opposite sides of the root. Okay. Okay, so let's go to graphical method. So the simple method for obtaining an estimate of the root of the equation f of x is equal to 0 is to make a plot of a function and observe where it crosses the x-axis. So this point, which represents the x value for which f of x is equal to 0, provides a rough approximation of the root. So this is the simplest methods. So i-graph lang natin yung yung mga values. So one example is below. Use the graphical approach to determine the drag coefficient needed for a parachutist of mass m, which is equal to 68.1 kilogram to have a velocity of 40 meters per second after free-falling for time t is equal to 10 seconds. So note that the acceleration due to gravity is 9.81 meter per second squared. So how will we compute that? So we can use Excel again. Kailangan go check on graphical uh, methods. So we already have the formula f of c for the roots of value of c. Okay. So we'll use the Excel to compute for the value of c. Okay, so we'll write here the c. Then functions of c. So many. Why? Uh, Bucket. That is text. Ayaw. F of C na lang. Yon. So we'll already have the value of the mass 68.1 kilogram and the velocity of 40 meter per second and a time t which is equal to 10 seconds. So dali na lang, no? So for the value of C, it will depend sa inyo kung asa ta mag-start of step size or interval. So pwede po every 1, 2, 3, 4, or pwede po every 2, 4, 6, 8, 10, or ang example sa book is every 4 siya. Or pwede po every 3, 6, 9, 12. So ay lang mo mag-start sa 0. Okay, so in this case, we will start from 2. So from every 2, okay, so f of c, that is equals to 9.81 times 68.1, that is equal to, where's my calculator? 9.81 times 68.1, 668.06, that is 668.06 divided by c. So this is the value of c multiplied by 1 minus e. So the value of e should be minus, for the value of e is 2.718, 2.718 to 8 raised to negative, that is m times t, cmt raised to c. Okay, nawala ko. Okay, that is e raised to negative c divided by m times 10. So we have the value of time 10 divided by the mass 68.1, that is equal to 0, negative 0.1468, 1.468 for 3 times c. Okay, then close parenthesis minus the velocity v, which is equal to 40, then negative 82 points. So parang may mali sa formula, so 1.2 erase. Ayan na natin ito, close parenthesis. So that's it. So that's the value of f of c. Okay, then let's check when the c is 4. Ayun. So if you can see, nagkaroon ng change of sign sa between 14 and 16. So kung asa na nag-change of sign, so ibig sabihin doon nag-cross yung yung graph. So between these two, andito yung roots of the equation when the velocity of is 40 meters per second. So what we will do next is graph natin. So insert graph. So the x and y. Insert. Okay, so that's the so base sa graph, so in-adjust ko yung ano sa x value. Okay, so base sa graph, ang roots of equation is nandito na part between 14 and 16. Okay, so we can also increase the value of the x para mas makita nating maigi yung roots. Let's say every 1 or 0.2. So from there, makita natin yung value ng x. 8 na. Oh, di na siya makita. So as you can see, in-adjust ko lang maigi yung graph ko para mas makita kong maigi kung saan nag-cross. So this is the zero axis. So andito siya na part between 14.5 and values of 15. So more or less 14.5, 14.8 approximate value ng roots of equation or the drag coefficient value at time 10 seconds when the velocity is 40 meter per seconds. Okay? So, ang ating estimate ay nasa 14.8. So, let's check. So, ang ating value ng f of c is almost equal to 0. So, ang ating f of c is equal to 0. Ibig sabihin, malapit na yung ano natin. Maliit na lang yung error natin. Okay, so the value, the roots of c is 14.8. Let's check kung 14.75. 0.09. Okay, so mas malapit tayo. 14.8 or 14.9. Let's check 14.9. Negative na. So, 14.85. Yun. So, malapit, no? 14.78. So, ayun. Okay. And for the solution sa book, so, ayun. Almost equal to 0. Then, we will substitute the value of c or drag coefficient to the original equation. So we can compute the value of velocity that is equal to 40.1 something, so which is very close to the desired for velocity of 40 meter per seconds. Okay, so madali lang yung graphical methods, no, but graphical techniques are of limited practical value because they are not precise. But graphical methods can be utilized to obtain a rough estimate of roots. So these estimates can be employed as starting guesses for numerical methods discussed. So graphical interpretations are important tools for understanding the properties of the functions and anticipating the pitfalls of the numerical methods. So as you can see in this figure, okay, It shows numbers of ways in which roots can occur or be absent in interval prescribed by a lower bound xl and an upper bound xu. So depende siya sa functions or mathematical expression, no? Or depende sa graph. So in this sample, okay. So as indicated in figure A and figure C, as you can see, the uh, lower bound x and the upper bound x has the same the same sign, but ibig sabihin nun, there are possible na walang roots or there are two roots. So between the values. So ano yung advantage sa sa graphical method? Pwede mo siya ma-visualize yung expression, yung functions. Okay. So in figure B and D, so in the upper and the lower bound of x is may mga changes sa sign, no? Negative and positive. So there's possibility na ang isang root ay only one root, and sa D naman, or composed of more than one or three or two or more roots. And another figure sa right illustrates some exceptions to the general cases. In figure A, there are multiple roots that occurs when the function is tangential to the x-axis. So tangent siya sa x-axis, no? So we have two roots. So for this case, although the endpoints are of opposite signs, there are an even number of axis intersections for the interval. Okay, so this is the interval. So for letter B, figure B, this continuous function where endpoints of opposite sign bracket an even number of roots. So special strategies are required for determining the roots for these cases. So mahirap kung ito na figure letter B ang graph. Okay, let's have some another example. So here's the problem. So the function f of x is given as f of x equal to sine 10x plus cosine 3x. So it has several roots over the range of x is equal to 0 to x is equal to 5. So ihatag ang lower bound x. So ito yung mga boundary, kumbaga. X is equal to 0 and x is equal to 5. So this is the lower bound and this is the upper bound. So use computer graphics to gain insight into the behavior of this function. So again, we can use the Excel or MATLAB. So Excel lang ta. Okay, let's try to have some input the value of x and the functions of f. Okay. So first, ihalagan tag bound of 0 to 5. So bahala na kayo kung anong interval yung gusto nyong gamitin. Okay, so from 0. So let's say to every 2.5. So 0.5 hanggang 5 daw. So there you go. So f of x is equal to sine 10x. So sine 10 times the value of x plus cosine of 3 multiplied by the value of x again. Let's check. So the value is equal to 1. Then drag lang natin pababa. Okay, so na ay mga changes. So let's try to graph. these functions para makita na to ang kanyang behavior, what will happen. Oh, na. Oh, na. So, yun. So, ang daming roots. Oh, no. Dami. So, let's check the mas maliliit na intervals. 0.1. 0.2. Let's check kung ano magiging behavior nung graph. Hanggang 5. Dabi. 5. Okay. So we will have the graph. Okay. So nakita natin yung graph. Ganito na itsura niya. So nilagay natin yung interval, no? So as you can see, ang daming points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this point is hindi siya nagtatouch. So ang dami niyang touches sa x-axis. So ganun karami yung roots niya. Dami. So as you can see, dinicrease natin yung intervals. So lumabas ang dami namang roots. Okay? So let's try again to decrease it more. So dinicrease ko yung interval from 0 to 0.01, 0.02. So ito na ngayon yung graph. So mas dumami ngayon yung mga possible roots niya, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ang dami. So yung kanina dito na part, yung mas mataas yung interval natin. Halos parang hindi siya nagtatouch sa x axis. Pero kung titingnan mo ngayon, halos nagtouch na siya. No? So in this part, no, between 4 and 5, let's check the bounds. So between 4.0 dash to 4.4. So nakita niya between 4.2 to 4.4. So meron na namang dalawang roots. So 4.2 to 4.3. O, diba? So very crucial yung it's a graphical method. So nakadepende sa interval mo yung values ng mga roots of the functions. So pwedeng mas marami or pwedeng mas kakaunti. So nakadepende siya sa interval. So kaya nga hindi siya masyadong precise or accurate yung pag-solve mo sa roots of the equation using a graphical method. Okay? So let's proceed to the next method.